So I'll get started. Hi everyone, welcome here to be with me for the Launch with CNRG talks. So today our topic is data management. My name is Yifei Kang. I'm the research data management specialist at CNRG. So I'll get started. So what is data management? So according to Oracle, data management is a practice of collecting, keeping, and using data securely, efficiently, and cost-effectively. So there are a few keys to data management. So where is my data? That's a computer equivalent of knowing your address. How is my data organized? That's a digital equivalent of keeping your home unclustered. Is my data protected? It's a digital equivalent of getting a secure system. What data resources are available? We are all the digital equivalent of real estate tycoons. And how will my data be shared? That's a digital equivalent of inviting friends over. So whenever you go to any IT department about question of your data, so the first question we will ask is, where is my data? So here I listed a few available resources on campus. So in IGB, there are the IGB file server, BioCluster, the high-performance computer system that you can use to analyze your data, the bioarchive, the long-term data storage archive system, the biodatabase, the MySQL database server. So those are here in IGB. And on campus, we have the Illinois Data Bank, Nightingale, UFI, Box.com, and many, many more. And I also list answers that are not so good. So like on the IGB server, so there are a few IGB servers I mentioned before, so you want to be specific where your data is located. And in the cloud, there are also all kinds of cloud services. You don't want to see someone else knows, or it's in the vault, or in my lab somewhere, or you don't want to see it's in a USB or hard drive. And because most of us here are using the cloud-based storage system, so here I'm doing a side-by-side comparison of the commonly used ones on campus. So from left to right are the UFI box, Google apps like Google Docs, Google Drives, and Microsoft OneDrives. Each one has their limitations. I'll talk in more detail. So for the total amount of storage per person, UFI box and Google Apps right now has unlimited storage, but it will change next year in 2026. It's set to be reduced to 200 gigabytes per person. And Microsoft OneDrive, so everyone have 100 gigabyte for free, and there is another version of license can be purchased by the department that is 5 terabyte. And there is also a single file size limitations. For Box, it's 150 gigabytes. Google App is 5 terabytes, and OneDrive has 10 gigabytes. And sometimes people have data that requires more protections, like the FERPA data that contains student transcript or record. It's not allowed to put on Google Apps. And electronic health, protected health information such as the HIPAA data, like the electronic health record, it's not allowed on Google Apps or OneDrive. There is a version of Box that allows HIPAA data, but it's different from the common ones we use. And if you scan the QR code here, there are more comparisons of each one. There are more detailed information listed in there. And I'd also want to talk about some of the cloud-based storage systems specific for Box, or it might also apply to other cloud storage systems. The folders can be classified to user folder or a group folder. So for a user folder, the data in there is private to one person. So it's not shared with anyone else. But you can share the data with someone else, but the person of the folder own the data itself. So you never want to share your password with anyone else. So because of that, if someone leaves the university, the data in that folder is going to be removed. So even if it's shared with you, it's going to get removed. And another one is the group folder, so which the data is shared private to a group of users. So because of that, data can be easily shared between the users in that group, and the data on that folder will stay in place when someone join the lab or leave the lab. So data will not get affected when people leave. How do you know whether the folder is a user folder or a group folder? If you on a box, you can under the sharing tab. If you see the owner, it's a person's name. That is a user's folder. And if you see it's a UFI box enterprise, that means it's a group folder. So people can come and join the group, and the other people in the lab can still have the data. And now the next question is, how is my data organized? So there are a few common ways. So the first is by lab member. The data in there is stored in a group folder, but folders for individual users are located within. So as you can see, there is a lab folder, and inside of the lab folder, it has a NIT ID of each person. Their data is under each person's folder. And another one is by project. So in this method, data is stored still in a group folder, but the folder for separate project are located within. So you can see this is a lab folder, and under the lab folder, each sub directory is a specific project, and for each project, it has their own subfolders. And another one is by project with metadata. It's similar to by project, but has a added text file to notify the change of the project. So here I have a new folder named NFLD October 2025. Compared to the other one on BioCluster 3, there's a metadata folder to notify any change of the project. And besides of that, there is another projects.txt file that record all the changes for the lab for the entire project. And what are the pros and cons for each one? So by lab member, so it's easy to know what data is under whose control because it's ordered by name of the folder. And it's easy to know what data needs to be reassigned when someone leaves the lab. And you can still copy and share data between users easily because it's under the same group folder. And the disadvantage of this method is when someone leaves the lab, decision needs to be made about who to take control of the data next. Because of that, data can stay there for a longer period of time without touching. And it's unclear what needs to be saved, archived, or shared, because everyone will have their own way to store the data or their project. It is the most used structure here in IGB and maybe on campus, but it has shown to be inefficient. So what about by project? So it's easy to know what data needs to be archived because everything is organized by project. It has been shown to lower storage costs compared to by lab members because there's no duplicate copy of data here and there. And disadvantages, most data don't get archived until the end of the project. Some project can be run for years and not get archived until it's finished. And it's hard to determine who should get access. Maybe there are multiple people working on the same project on a different part of the project. And it's harder for user to take responsibility of the data because they don't know if someone else is needing that. They don't want to touch the data someone else is going to need. And it can be difficult to tell who is doing what. This is a less common but more successful version of storing the data. And the next one is by project with metadata. So the advantage of this is it has log files to indicate what work has been done or performed or needs to be done next. It's easy to track who's doing what because of the log files making changes, and it's easy to know what needs to be done next. And it also helps to simplify project management because of the metadata. But this is a more time-intensive method and needs buy-in from the entire team. So everyone in the team needs to be responsible to log whatever they are done or they are being doing or what's going to be done next time. So this is our preferred model for structure, but it needs effort from everyone in the group. Here it's an example of that project structure with metadata. So on the left-hand side, it's a project in a tree structure, and on the right-hand side, I have some comments of what folder is doing. So start from the top to bottom. There's a README file to have some basic description of the project itself, and the lessons file if this project is going public online. And the metadata folder here, at least common ones that can be useful. The project metadata have some project level information about who is the PI, what funding it comes from, or what's going on for this project. And sample metadata that has information of the sample ID, species, or the treatment conditions. Experimental metadata for the protocols or reagent of the dates. And the next folder is a data folder. So I have a raw data folder. So here in IGB, most commonly we get data from the sequencing center or the core facility for the imagings, and another folder for the reference file that you can use to decode your raw data. And the next folder is a process folder. That's a clean data that you can run for your analysis. And the next folder is the SRC folder. That stands for the source code. I have a list of few that is commonly used. So the first one is pre-processing. That can be your bioinformatics pipeline for your raw data. And the next few, the training evaluation, if you have some AI projects need to have some training and evaluation scripts in there. Analysis folder for the statistic analysis code and visualization if you want to for your publications, and I also have utility if you have some small scripts for your functions to import. It's also in there. And result folder, I divided into figure tables and reports that can be go for your publications. And documentation for supporting documentation of protocols. And several optional ones are the config file, config, model, and environment. That's for some AI or coding intensive project. And here I also list the temp file, because most of the time your result is not final or your script is not final. You need to do a lot of play around for what you want to be done. So I have a temp file in there so that you can play around but not finalize things in there. And the archive folder for backup of old script or data or some even old version of the file. If you use BioCluster, we have recently made this into a module named create_project. If you load the module, run the Python script, it will generate an empty project structure for you. Next, it's the project metadata. I have an example here. So on the top are the basic project information, the project name, what it's doing, or what organism it's using, or the sequencing information. You can put this in here. And I also want to point out the bottom part. It's a project timeline, so that people can log what they are doing for this project. This can be helpful for yourself if you come back for a longer period of time and you didn't remember what you have done, or you are taking over someone else's project, or a new team member joins and you know what has been done for this project. Okay, so now we have talked about where is your data and how your structure should be organized. So the next thing is my data protected? So here I would like to introduce the 3-to-1 data backup rule. So that is, you want to keep 3 copies of your data on 2 different media, one of them offsite. So this method helps to protect you from accidental deletion or device failure, because you can always have an extra copy of your data. And for the off-site copy of your data, it helps to protect from natural or man-made disasters. So for example, if the building has flood or it's hit by a tornado, you can still get your data from a different location. If you follow this 3-2-1 backup rule, it virtually guarantees you to not lose any data. And so what not to do? You do not want to have a single copy of your data. Even if you store your data in the CNRG server here, you will still be one failure away from lose all of your data. And you do not want to have your data stored on a removable storage devices because they are easily get stolen or lost or it has device failure. And you do not want to have your data on a consumer level storage system such as a private server or removable media, loose drive or local computers. Because the consumer level storage system, they are less controlled environment. And the environment is usually not monitored, and the data is not consistently checked for the health. And so because of that, we would want you to use the enterprise storage services, which we already have here in RGB. And because it's managed by IT professionals, and scientists are busy doing their research, they don't have to handle IT themselves. And we have a team of experts with experience to take care of the data for you. And the enterprise storage service, the data there are monitored for health. So we have spare hard drives to replace the old ones that are filled. And we will get notification if one of the drive fails. And our data server is kept in a secure, controlled environment. So we have backup powers, and the environment it's monitored, and we will get notification if the environment turns bad. And if you are still unsure which service to use, you can always come to us. We can help you to find the best solution. And here I want to show you some of the RGB file alert we get. So this is a drive alert. We will get an email if in our server room one of the drive goes bad. We'll get an email and we'll have people get in there and replace the drive for you, and you will not notice. We also have environmental control. So we have a backup power, and the server room is monitored for temperature and humidity. And the environment is under control. If you see a red X mark in here, it means in this picture specifically, it says one of the cooling system have leak. So we'll have people go in there and fix it. So here I'm going to talk into more detail about data resources. So in RGB, we have the RGB file server. It's a free service for everyone in RGB to use. Each scene, there is an allocation of 20 terabytes of data to use. It has a faster transfer speed. And the data on there is backup daily. So for the 3-2-1 data management rule, it means 2-1 here. And on the bio database, it's a MySQL database to store smaller bits of data, even if it has very large numbers of files there. Bio database is directly connected to bio cluster. It is a 2-1 data storage system. BioCluster and BioArchive, I guess, it's the most popular services we have. So BioCluster, it's a high-performance computer system that you can use to analyze data that you need very big or large computational power. It is fast in transfer files, but it has a monthly cost. However, BioCluster is not backed up, so you do not want to put your only copy on BioCluster. And BioCluster doesn't work very well with many small files, so you don't want to keep many small files in there. So BioCluster means its data storage is 110. In terms of BioArchive is a disk-to-tape storage system that is meant to long-term storage of the data. It has a fast data transfer speed. So what we've done here in RGB, it is a long-term storage for upfront cost. So we charge you for the storage cost, and we will not bother you for 10 years. So the data will be safe with us for 10 years. And because it's a tape storage system, data cannot be changed after you write your data in there. Yes, Jenny?
What's the scale of many small files? Hundreds, thousands?
Maybe we have people have millions of files on small files on BioCluster, so that's we do not want to do.
I would say once you get to 100,000, like that's too many.
Yeah. Okay. On BioArchive we have 221. So the one offsite storage it's a Air Force bunker, like located in run 2. So if you lost your data here, we can still go there to grab your data back. So here you can see BioCluster and the BioArchive together will be a 3-to-1 data management backup rule. So what we would recommend when you get your raw data from the sequencing or the core server, after you validate your raw data, you put an extra copy on the BioArchive system. So in case anything happens, you can still have your data securely restored. And in terms of on-campus resources, we have Illinois Data Bank. It's free for publishing data. It stores data for 7 years. And after you deposit your data to Illinois Data Bank, it has a unique DOI you can use to cite it in your publication. It is a cloud-based storage system, so I assume it's 111. And Box.com, as I mentioned, it's currently unlimited and free, but will change next year. It's a cloud-based system. It's great for collaborating teams, writing documentations or grants, but it has file size limitation of 450 gigabytes. It has slower transfer speed than other local services. It has no backups, so it's similar to Illinois Data Bank. It's a 111 here. And on campus, we also have other resources. Campus Cluster is currently subsidized by the campus, and you can transfer file by Globus or SFTP. And how Campus Cluster works is you buy the disk in advance and you do your work there. It's like BioCluster, but different option. It's good performance, but it also has no backup, so it's a 110. And Tailgate and Granite are the data storage system. It has lower cost than the Campus Cluster. It's similar to BioArchive, but if it's not an external copy, and there it's also have a monthly cost, so it's a 110. And for some HIPAA data, on campus we have the Nightingale, so it's also subsidized by campus right now. You can transfer your file with Globus or SFTP. It is pretty good for transfer of data, but it's not backup, so it's 110. And Box has another HIPAA Box version. It is similar to Box folder, so the limitation is similar, so it's 111. So besides, there are some public repositories that are available. The public repositories are preferred by NIH and other funding agencies. So NIH itself has 147 of the repository listed. Commonly used here in IGB are the GO and SRA to deposit sequencing data. And another popular one, it's not hosted by NIH, but it's a European organization. It's the Nodal. So next is you want to share your data once you have your data stored and everything working out. So when it talks about sharing your data, you want to follow the FAIR principles. You want your data to be fundable, accessible, interoperable, and reusable. Because the grant funding agencies are expecting you to share your research findings after the project is complete. Technically, all the research data created here in the university belongs to the state of Illinois. So personal responsibility for data is good, but we have to do whatever required by the university and the funding agencies. And ultimately, the share of the data and the conclusion, it's a purpose for research. And I will list some common methods we use. Public repositories, as I mentioned before, they are preferred by most grant agencies, and they are free, and they can deposit data as it's created, such as GO, SRA, or the Nodal. And if you do not have a good repository to go, Illinois Data Bank is also a good option. So it is free to use on campus, and it can also deposit as created. You can create a go live time when data will be shared, and it will have a DOI, so you can cite your data. And it's being said that data will remain on the system for 7 years, but as far as we know, they haven't deleted anything yet. And some poor method you do not want to use it to be available upon request, because the funding agencies consider this is adding obstacle to sharing your data. It's put obstacle between scientists and the data. And sometimes after the grant it's finished, there will be more support from the team to provide the data if someone else requests. And another one is deposit with publication. I mean, only deposit with publication, because publication is not meant to stop you from sharing your data, and it's unclear of information on retention, and sometimes there will be a fee involved to get access to the publication or the data associated with it. And after the data is deposited with the publication, PS usually have no control on how they want to be returned. And sometimes data will not go into publication, but the funding agencies still want you to share your data. And in terms of sharing data, most of the funding agencies now requires a data management plan to come with your proposal or your project. Here at RGB, we offer the data management plan service for free. So if you have your proposal draft or data management plan draft, or you want a second eye or comment on that, feel free to contact us. And I think that's all for today's talk. I put a data management page of CNRG here. There are some best practice of data management. You can go to that link. And with that, I would like to take any questions. We have a mic box there.
Yes, this is just a microphone.
Well, you can throw this around. What do you have any more details about the box limitation that's supposed to come through next year? Is it going to be, you said 200 gigabytes, but it's per person? Is that also per group? They don't have that decided yet. What do you do if you have more than 200 gigabytes on there now?
We don't have details yet, so that page I shared earlier, that's the most up-to-date information we have. They are aiming to change that in June of 2026, if I remember that correctly. Yeah. But we'll keep everyone posted if we have more updates. Any other questions? Okay. Thanks everyone for coming. And yeah.